All right, so you have two. Remember, the X is anything that affects horizontal. The Y is anything that affects vertical. This is where your negative 16t squared has to come in so that it forces this to turn. So a golfer hits a ball with the initial velocity. Put your velocities in. It's going to glare from this window. Put your velocities in. Don't forget your t, your cosine of sine, your angle that he hits it at, angle of elevation. And there's nothing else going on here. This part here, we're going to look at on your graph. So, okay with the equations? Did anybody struggle with this problem? Okay. Okay, so let's put this in your calc. Make sure you have a calc handy. My mode is parametric. The one good thing is this mode doesn't affect my statistics one, so I don't have to keep switching them back and forth. Cosine. Don't forget this minus t squared, otherwise it's not going to come down. Okay, let's talk your window. So a golfer hits a ball. Time. We're going to start our time at 0. He's going to only be in quadrant 1. Maximum time, 10 seconds. 10 seconds. Leave your t-step. You can always change this t-step and make it a little bit closer once you see it. You're not getting a lot of time on this, so you can make your t-step a little smaller. Your x-min, we're going to set to 0, and your y-min, we're going to set to 0. Now, your x-max, that's your horizontal distance. I really don't know how far a guy hits a golf ball, so in terms of feet, anybody golf out here? 300? Julia, so how far should we set the x? The horizontal, if we need to just set the window. 500. And the y max, probably like 100. Does your ball go more than 100 feet in the air? Okay, so look, we missed this golfer has a nice swing. He has a strong velocity. So we missed this part. What should we change? X. So just play with this a little bit. If you find you are so far off, then look at your table. You'll be able to see your turning point. So I'm just going to make it 600. I just need to be able to see a turn. And on my table, am I looking at my Y or my X to see it turn? Your Y. Don't forget your X is constantly increasing. It's horizontal. So if you start looking at your X to turn, it's not going to happen. That's the increasing one. Your time is your parametric one. That's the one that's going through your curve. And your Y, this is perfect. He hits the ground somewhere between 4 and 5 seconds. That's how long his ball is in the air. There's my maximum height. So if you struggle with your window, here it is. Here's your vertical distance. Like make it 100, somewhere in the 90s, somewhere up there. Here's your horizontal distance. When it hits the ground, make it like 600. So we're close enough. Oops, sorry. I had to bring my phone, and I forgot to shut the window off. I babysat my son's puppy last night, but he threw up this morning when he went outside. So I had to, my son's a fireman, so he's getting off now. So I had to tell him, I fed the dog, but before I fed him, I had to wait because he threw up. He must have ate something outside. As he came in, you know, when a dog has to throw up. So I quick brought him back out, and he threw up twice. So I didn't know if I should feed him or not. So I just wanted to tell him, so he just texted me. Sorry, I never bring my phone with me, but I just wanted him to know that his puppy threw up and I didn't feed him. Okay, so I'm sorry. So back to this. It's like having a baby. He's my grandpuppy. I have a little sign. I love my grandpuppy. Yeah, I think I watch him more than my son does. So yeah, as I clean his house more than he does. Yeah, that's why he likes me to stay over. It's like, can you stay and watch the dog? Can you finish my laundry? And I left dishes in the sink, and yeah, I have to vacuum. The whole 9 yards. So some kids just don't grow up. But that's okay. So I'm sorry. So now, so we can set your window from here should you struggle. Not all of them are this easy. But what else gives you a nice little hint is this. So I want to be at least 275 feet away. I need to be at least more than that. So now, I want to know where and when does it hit the ground. So do your trace. Here's your trace. Now your trace is giving you time, horizontal distance, vertical distance. So I need to know when this gets close to the 0. If it's before the 0, it didn't hit the ground yet. So when I come to here, 4.6, I'm slightly below the ground at 5. So maybe I want to look at my table and start my table at like 4.7, 4.8, somewhere around there, and just leave it like that and see where I am. So 4.7, I want to be right in between here. So I'm getting a little close. So now if you want to set your table set at 0.001, the unfortunate part is you need 3 decimals. So if you want to get a little closer, you're not too far to do this. If you find that you're too far and this is pretty far away, just reset your table. Start at 4.8 and look. Am I closer? Start at 4.9 and look. Am I closer? Okay, now you're below the ground, but maybe you just want to go back this way. You want to get the first negative number, this guy. You didn't really hit the ground yet here, but you hit the ground there. Okay, so here's when you hit the ground, 4.886 seconds. Here's, so if you're around there somewhere, I'm fine with that, 0.885, 0.886. And here's your horizontal distance. Just scroll over it, because there's not enough room, they round it, and we need 3 decimals. So actually, 7.30 is fine. If we're looking for this guy at 275, how do you find that? If I want to know, did I clear this fence? There's a fence 9 feet high at 275 feet away from the golfer. How do I know if I cleared that fence? What do I look for in my graph?
275 feet.
X or Y? X. Good. So I'm going to trace. So Lily says watch the X. See when you get close to 275. So here I am at 268, and look at my height. I'm 95 feet up in the air, my ball. That's almost at the highest that I'm going, isn't it? So if I go a little bit more, I passed my 275. Am I still well over? So do I have to really fine-tune this? No, I can very easily say between 2.5 seconds and 3 seconds, I clearly am over the 9-foot fence. Just give me the 2 pieces that you do, and you do not have to fine-tune that. You're clearly over. If this said 90, I might want to get a little bit more fine-tuned to this because this is a little high. I might want to drop this down and see. You can also change your step here. This helps, 0.01. Sometimes 0.01 is not too bad because you're really not going that many seconds. If you're going to go like a couple of minutes or something, then I wouldn't set it so slow. But that one's not too bad because now you can watch your time step increase. Still a little bit slow, but not too bad. You definitely don't want to do the 0.001 on your T-step because you'll be there. Oh, anybody try that? Yeah, you'll be there a while. That's with anything that you graph. You see those little things up here? Even when you graph a regular y equal, you can't do that until it's finished. It's still going. Because technically this graph doesn't end here. Technically that graph keeps on going. So it's got to find a stopping point.
You hit second on.
Yeah, to shut it back off and on again. Yes.
And on my calculator it stops it.
Oh, it stops it? Oh, very good. So now if you do your trace, you're going to be in a smaller step. It's just going to take you a little longer to get there. So, play with it and get a feel for it. So yeah, we know how far it is, how far away it is. Does it clear this fence? Just give me the 2 pieces and say yes. You don't have to fine tune that. If you're close, And yeah. Good? Okay. Alright, let's see the next one. The batter hits a ball with a velocity of 92 feet per second at an angle of 55 degrees from the horizontal. Find the maximum height attained and the total horizontal distance traveled by the ball. Now, when this batter hits the ball, he's not really holding his bat up here. He's like holding it on the ground. We don't have any extra movement here. Normally, you hit the bat like 3 feet off the ground, right? You hit the ball when you're not golfing it. You're hitting it up here. But this one doesn't have one. So normally, you would have to change this. Your vertical would usually say like +3 feet off the ground. That's where you initially hit the ball, but it doesn't have it in this one. This is just to let you get used to how to set these things up. So again, here's your equations. They work the exact same. Don't forget the t's, and don't forget to bring the -16 back down so it comes back down. So let's put this guy in. Remind me to reset my table, my window. So we're going to put 92 T. Okay, so now let's play with your window a little bit. I'm going to change this guy back to 0.5. And you can make it 0.2, you can make it 0.4, whatever you like to make it. Maximum. Horizontally, what is like a baseball field? 325 feet? So let's say 350, let's say 400. Just kind of an estimate. Oh, that's my min, sorry. So 400 feet. And let's say in the vertical, let's stick with 100. Okay, you can always redo your windows. You can even first look at your table. As long as you get this, don't reset it. You just need to be able to trace it down to where it hits the ground. So you want to know the maximum height. So what am I looking for? Technically, the vertex. Good. I'm looking for its vertex. I'm looking for its turning point. Now, sometimes you hit it perfectly in your graph, and sometimes you don't. So if I look at my graph, do I hit it? Nope, I don't hit it perfectly. Sometimes you'll see symmetry, and you find the symmetry with a parabola. Sometimes you see it, sometimes you don't. So if I hit the ground between 4 and 5 seconds, I could see where my vertical distance is, my vertical distance, my horizontal distance, and my time. So you want to trace until you get to that maximum point. Then you kind of have to judge this one. So I would say a little bit before 2.4, right? A little bit before 2.4 probably. So start your table, 2.4. And is everybody okay finding these? Are you seeing it now? Okay, now the tricky part about this guy, you're looking for your turning point here. So I'm decreasing. I want to find the point where I increase, turn, and decrease. I'm still decreasing here, so I haven't turned yet. So I keep on going until I turn. I'm 20, 19, somewhere right in here. Did I turn right in here somewhere? No. Where am I? 22? It's still going down. Okay, it's still going down. Sometimes you're going to see like these kind of stay the same for a while. Now look when they're all the same. It doesn't mean that they're exactly the same. If you go over here, you're going to see your decimals change. So you're going to have to watch your decimals a little bit. If you get close enough to this, I'm fine. This one is still, in terms of 3 decimals, 0.741, 0.741, 0.741. They're all the same. But watch this guy. See the 0.08? That's like 0.01, 0.08. It's going down a little bit. It's going up from here to here. So it went up, then it decided to turn. Now you see it going back down? You're going to have to look a few more decimal places out. We were here. This was 0.08. I'm up, then I'm going down. See it? So somewhere, if you give me one of these times, I'm fine with it. You just get close enough. And I wanted to know how high. Make sure you give me the Y, not the X. The Y is your vertical.
Do you need to say the times even though they only ask?
Yeah, you need to tell me the time. Yeah, I need to know the time because that's how I can find it on your graph. Like if yours is a little different than mine, I should be able to put it in and then find your time. Because what I'll do is I'll just go to put a value in, and I'll put your time in. So if you told me 4.555, I'll go to 4.555 and see what your max is. You know, whatever time you give me, because sometimes if your formulas are off, then I'm off. Okay? Does this make sense? Not bad, right? Do you do anything? All right, so let's make our equations. First one. What's your velocity? 103. Don't forget your T. I'll do them both. If the ball is hit at an angle of 43 degrees, always start like this. Again, the guy is hitting it off the ground. Technically, he should hit it like 3 feet off the ground. So let's make him hit the ball 3 feet off the ground. When you go to hit a baseball, from here to here, you're about 3 feet up. So what do I do with the 3 feet? He's not going to hit it off the ground. He's going to hit it where, like, mid-level here. Add it where? To which one handles the vertical? The Y. So I'm just going to put the +3 right there. Okay, let's put him 3 feet off the ground. All right? Do we have any other thing that affects us? No. Okay. So let's get started. Yes. No, not unless I told you. But this time I'm going to add the 3 because technically that's where you hit the ball. I like 3 feet off the ground. So we're going to be a little more technical on this. So we're going to change these guys. Get that going. Get your graph in there and set your window up. Does it matter which one I put first, the -16t squared or the +3? Doesn't matter. Okay? We just did a baseball one, so let's try and see if it fits the same window. How different can baseball be, right? So it fits the same window. So we're in luck. There's not a lot of applications other than shooting a rocket, shooting an arrow, hitting a baseball. You know, anything that you're throwing, shot put, anything that you're throwing in the air to come back down.
I would reset my window.
You reset your window. Okay, so let's go to the window.
Yeah, no.
Because your path is 300 feet away, X max has to be at least 300. So make it be like 350. Don't fine tune your window. Your window is just for you to visualize your graphic. So if we did this, here's our sketch. Our ball is coming now 3 feet off. Whoops. My ball is coming 3 feet off the ground. I didn't exactly start at the 0. So it's coming like this, and it's going to reach a fence and see if it clears that fence. So somewhere 300 feet away is my 10-foot fence. I want to know, does it clear that ball? Does that ball clear that fence? Does it reach 300 feet at least vertically, horizontally, and 10 feet vertically? He's got to hit it over the fence. So let's take a look at this. All right, so we've got this. So what is it I'm looking for? 300. So I'm going to trace until my my horizontal distance, your X, is 300. So here I am right here at 301. So I pass the 300. I look at my Y. My Y is 27 feet. Did I clear the fence? Did I hit a home run? Mm-hmm. So all you have to give me is this. C is equal to 4. And X was equal to 301 something, whatever it said. I don't remember. And this was 27 point something. So did you clear the fence and hit a home run? You have to say yes. Yes, they hit a home run. So he's pretty cool. He hits a home run. All right, so now the second one. We're changing number 7 a little bit. Something's weird with this board. Okay. We hit now at an angle of elevation of 41 degrees, and we have a wind speed at our back in feet per second. So now, there's a wind blowing in the same direction as the horizontal path of the ball. So is the wind going to help my ball or hurt my ball? Helping. It's coming in the same direction, which means it's coming behind me. So if you ever were out on a windy day, even walking, if the wind is blowing towards you, like it's a little harder to walk. If it's behind you, it's moving things along pretty quickly. So if the wind speed is in your direction of your ball, with your direction, you're going to add it. If it's against you, you're going to subtract it. Now, this is nice because it's in feet per second. Sometimes they give you miles per hour. If they give you miles per hour, you have to convert to feet per second. But this is already feet per second. So we've got both of your things. I think he hit it at the same thing, 103. It's related to the other one. But he changed his angle of elevation. We're going to start basic. He changed his angle of elevation. We're still going to put him 3 feet off the ground. We're going to turn his ball back down. And the wind speed is helping this horizontal distance. So we're going to add this right here. And wind is a speed, feet per second. It has a time constraint. Now, if we gave it to you in miles per hour, you have to convert it to feet per second. But this one is already feet per second. So the wind should help the ball a little bit. So we go back to your graph. You're going to be in the same window, so that's kind of nice. You just have to change this a little bit. He changed his angle of elevation. We should have left that the same, just so that you get the effect of the wind speed. But he changed his angle of elevation, and we're still leaving him at 3. We're good at 3. But we're going to change this guy and add a little help to him. Make sure you put the T with your speed. Okay? That's another thing that gets left out. So now, what's happening to his ball? It's going further. It's pushing his ball further. 22 feet per second is probably a good strong wind. If I shortened it, if we went against him, so watch, I'm just going to play with this a little bit right here. If we shortened it, and the wind was towards him, watch what it does to his ball. It shortens it. So see the effect of the wind speed? All right, so all you have to do is play with it. Just play with these guys. They're actually pretty fun. You know, they're having fun with math somehow. So play with this guy. Again, do you think it would clear his fence? If he hit a home run before without the wind speed, do you think it would clear it again?
Yes.
Mm-hmm. Maybe not with the minus. If I change this to a minus, we might have a little trouble. Is it the same one though, or did they change it? Okay, here's number 8. Let's take a look at number 8.
Wait, so what was the answer?
Yes, it's going to clear the fence because it's the only thing that changed was your angle of elevation slightly, but it pushed your ball further. So you can just trace it and see where your 300 is. You're clearly over the fence. This one might not if we do a minus. So this one we have to worry about. So trace this guy. We want to see, what is it, 300 feet? Are we 300 feet away? 300 feet. So we want to look for a horizontal distance of 300. Now look where I am already. Here's 250. I hit the ground already. Did I hit a home run? So if you clearly show me that you're here at 250 at 4.5 seconds, and you show me just this answer right here and say, no, he doesn't hit a home run, that's fine. You don't have to be any more detailed because he didn't even reach 300 yet, and he hit the ground. So see what that wind speed does? Has a big effect. Okay. So we did 6, 7, and 8. We did 2 and 3. I think you just have 4 and 5. Let's work on number 4's equations. And you guys can do number 5 too. Okay. This one's a tricky one. Chris and Linda are standing 78 feet apart. So here, there, 78 feet between us. At the same time, they throw a softball towards each other. I throw that way, they throw this way. Linda throws her ball with initial velocity of 45 feet per second at an angle of inclination of 45 degrees, and Chris throws her ball at an initial velocity of 41 with an angle of inclination of 39. Again, they're throwing off the ground, so we're not adding that in. Now, you have 2 sets of parametric equations that represent this model. See if you can come up with your 2 sets. We need their balls to be opposite ways, right? We need one to throw this way, one to throw that way. See if you can come up with your equations. Anybody have a set of equations? What do you got, Lily?
For Linda, I got 45 T cosine of 44 and 45 T sine 44 minus 16 T squared. And 41 T cosine 39 and 41 T sine 39 minus 16.
Okay, so let's see what happens. So before you do this, just hang on 1 second. What should your window be? Let's check your window a little bit. Let's make them 10 seconds is probably a little high for them, right? So we'll just make them 8. Oops. T-max. How far apart are they? 78. So let's make this 100. And my vertical, I don't know, like 50. It's not that high. They're probably not throwing that high in the air. Now, watch. Watch up here 1 second. Look up here. There goes one ball. There goes the other ball. They're both throwing in the same. They're both standing over here throwing. So what do I have to do? They're both standing here throwing this ball. I want them 78 feet apart. Add 78. Who do you want to add 78 to? Linda. So was Linda first? Okay, so am I adding it to her X or to her Y? Her X. So I'm going to add 78 to Linda's X. Okay, let's see what it looks like. Chris threw Linda threw. But I want Linda to throw to Chris. So what do I have to do? Subtract 78 will put me back here. Well, reflect it. Good. So I have to reflect. We're going to reflect Linda. So how do I reflect Linda? Put a negative. So let's see if this works. Oops. How does this keep happening to me? Let's see if this works. There goes Linda throwing. There goes Chris throwing. Is that where I wanted them to be? Did either one of them reach each other? No, neither one of them reached each other. But did you see Linda throw and then Chris throw? Want to see them throw at the same time? Mode. Just hang on 1 second. Just come to simultaneous and hit simultaneous. Watch. They're throwing at the same time. Now, the X, because it's vertical. It's horizontal. Now, see how this is not so nice? I want to change my T-step. Change your T-step and make it just a little bit smaller. Make it a little smoother. See it? A T-step it tells you how fast those little increments go. So if they're only taking like 3 or 4 seconds to throw the ball, want your T-step smaller because it's not having enough space to make those increments. Guys, finish this one and number 5. We didn't finish answering the questions, but we do have your formulas.